So to kick off today's discussion on what's new for container security and Defender for Cloud, we'll be going over some of the security challenges as well as the software development lifecycle for containers, and then discuss the different options that we have for container security with the Defender for Cloud plans. And then from there, we'll take a look at what's new, and we're going to split this into two different areas. So first, we'll look at what's new for security posture. Then we will discuss what's new for the runtime threat protection. So first off, when we think of the software development lifecycle, the journey of a container image from code to cloud involves several important steps, which we're considering here in Defender for Cloud. First off is the application code, and this is developed, then built and tested and packaged into a container image. Then that image is stored in a container registry where it can be pulled when needed for deployment, and then the image is deployed to the cloud environment where it's run as a container. And throughout this journey, it's very important to have continuous monitoring and updates to ensure that the container image remains secure and it's up to date. And all these levels within the software development lifecycle needs to be secured because it only takes an attacker to find just one weak point within the system to attack. And with that in mind, there's also different container security challenges that we're considering as well. First of all, container environments are very ephemeral. These are short-lived applications that are spawn up and rapidly resized. Another thing here is that there's high demand for visibility and control. There's different data and configuration layers that we're looking at that need to be secured. And with containers in general, there's a depth of expertise needed and a shortage of skilled labor in this area. So with that in mind, this is where Defender for Cloud comes in. And Defender for Cloud is Microsoft's CNAPP solution, Cloud Native Application Protection Platform, which provides end-to-end container security across all big clouds and your on-premise environment. So we protect not only Azure, but also AWS and GCP. And to provide that end-to-end protection, we offer DevSecOps security to unify your DevOps security management, and also the cloud security posture management and cloud workload protection. So we help you to strengthen your security posture through looking at security best practices for your cloud environments, and also detect any threats that exist on your cloud workloads. And container security is a big part of the CNAPP story here. So first off, when we're looking at container security in Microsoft Defender for Cloud, there are different areas that we cover to help you discover your container estate and identify any risk to protect against breaches from cloud to cloud. First off, we offer the visibility, context, and risk. And here we're able to discover the inventory of your Kubernetes cluster without the need for an agent, and also allow you to query this inventory for your own advanced hunting. In addition to that, we're able to provide code to cloud contextualization, showing you where the image originated within your CI/CD pipeline, as well as show you any lateral movement that can be taken within the environment using the attack path analysis. In addition to that, we also provide the DevSecOps. So we're able to do the code scanning and scan images during build time to detect any vulnerabilities that might exist at build and provide guided remediation for those vulnerabilities. And then in addition to that, we also provide the cloud native posture and the runtime threat protection. With the cloud native posture here, we provide image assurance. So being able to discover vulnerabilities that exist in the image, including detections for OS and language packages, as well as exploitability. In addition to that, we provide daily scans for the image and images that are also running on the cluster, and secure deployment, so using an admissions controller to provide enforcements for different configurations that exist on the cluster. And all of this can be done with the image assurance. We're providing an agentless scanning here. And then with secure deployment, we also have, as I mentioned, the agentless, the admissions controller through the Azure Policy add-on. For the runtime threat protection here, we provide both agentless and agent or sensor-based capabilities. And with this, we provide a rich detection suite of over 60 different analytics here that are using Microsoft Threat Intelligence. And with that, we're able to map these detections to the MITRE attack chain and also allow you to export them to your SIM solution or Defender XDR. And we've recently integrated the Kube audit logs with the Defender XDR Advanced Hunting, which we'll show you later throughout this presentation. Now, in terms of how you can get container security with Defender for Cloud, there's two different plans that are available here. So you'll notice that we have the Defender CSPM, the Defender Contextual Posture Management Plan, and then the Defender for Containers. With Defender CSPM, it's more focused on posture capabilities, and everything here is agentless. So all the capabilities that are mentioned as part of Defender CSPM do not require an agent, and this includes the agentless discovery of Kubernetes, the vulnerability scanning, the scanning at build time and being able to map those images from code to cloud, as well as the Cloud Security Explorer and the attack path analysis. With Defender for Containers, this is a mix of both agentless and sensor-based capabilities. So you'll see here there is some overlap, but we provide these advanced container security capabilities as well, and provide the threat protection here in addition to agentless posture capabilities. So the added benefits that you'll see for Defender for Containers here includes agentless detections of the Kubernetes management layer, as well as sensor-based detections, sensor-based runtime detections as well, and the identity and the ability to block any Kubernetes misconfigurations. So taking a closer look here at what's new. So here we provide you with an overview of what's new, which is what we're going to be discussing today. And we previously released a blog in our Microsoft Tech community, which really covers these announcements and provides you with additional information that you're free to explore here. But taking a look at what's new for today's discussion. So first off, we released the Defender for Containers as generally available in multi-cloud. So this plan is now GA in both AWS and GCP. And we also added more support for Azure Government and Azure China clouds. We'll also be looking at risk-based prioritization recommendations, as well as the support for OCI and Windows container images as part of our vulnerability scanning, and the addition of Kubernetes CIS benchmarks across multi-cloud, and some new detections that we're adding with XDR, some custom-based detections, and the integration with advanced hunting. So taking a closer look at what's new in security posture. So from the posture side of the house here, we'll be discussing the posture capabilities that are available to you now that we're GA in multi-cloud. And we'll also take a closer look at the CIS benchmarks, the support for Windows and OCI and vulnerability scanning, and the new risk-based prioritization recommendations that we released for the vulnerability scanning. Okay. So with Defender for Containers being generally available in multi-cloud, that also means that the security posture capabilities are also generally available in multi-cloud. And this includes a couple of different capabilities here. So first off, this includes the agentless discovery of Kubernetes, which is part of our agentless container posture story. So we're able to discover your Kubernetes cluster without the need for an agent. using the Kubernetes API, and provides zero footprint here when discovering the cluster. So we can get full inventory of your Kubernetes cluster, view things such as pods, namespaces, etc., that are running on the cluster. And from there, we're able to use that agentless discovery of Kubernetes in different scenarios. So from there, we're also able to provide the attack path analysis, which allows us to see different lateral movements that an attacker could take to gain access within the cluster, and really allow you to focus on different risks that matter most for your environment. From there, being able to discover that full inventory of the cluster, we also provide enhanced risk hunting, which is using the Cloud Security Explorer, as you can see in this screenshot here, to actively hunt for different posture issues through using either custom queries or built-in queries, and search for different container-specific security insights, such as internet exposure, that may exist within the cluster. We're also able to, with the Cloud Security Explorer, provide the code to cloud contextualization. So once you build that image and deploy it to one of the registries that we support, showing you where, which build pipeline that registry or the image originated from. And additionally, the GA of security posture includes the container vulnerability assessments. And taking a closer look at the vulnerability assessments here, which is part of our image assurance journey. So now we've GA'd the use of the Microsoft Defender Vulnerability Management Scanner across all 3 clouds here. So essentially, you're using a single scanner across all clouds to provide you with a unified experience for vulnerability scanning. And this is all without the need of an agent. And we provide the vulnerability scanning for both the images that exist in the registry and also images that are running on the cluster. And we're also able to provide you with a continuous a rescan for every 24 hours of the running images with this new scanner, to provide you with a more accurate and up-to-date view of the vulnerabilities that exist within your container images. And with the scanning, we're supporting both OS and programming language packages. And in addition to that, showing you the exploitability insights, which will show you if that vulnerability could be exist in an exploit kit, or if any exploit steps have been verified for the CVE. And we'll take a closer look at what all of this looks like for you in the portal. So I've gone ahead here and navigated to the Defender for Cloud portal. And as I mentioned here, we released the GA for Defender for Containers in AWS and GCP, and just taking a closer look at what the onboarding would mean. So in the environment settings here, you can see all the multi-cloud environments that you've onboarded. And I've already onboarded my GCP project. And when looking at the configuration for different Defender plans, I can see here I have the Defender CSPM, which is one option, and the Defender for Containers, which is now GA. And in the settings here, you'll notice for the security posture capabilities, you'll notice the agentless discovery of Kubernetes, and then the agentless container vulnerability assessment, which is available for the Google container registries and Google artifact registries, and running images on the GKE cluster. So to get the posture capabilities, I need to make sure that I have these 2 plans turned on, or these 2 extensions turned on. The other extensions here are also part of the threat protection capabilities. So once I've turned on the agentless discovery for Kubernetes and the vulnerability assessment, So for the vulnerability assessment here, one thing that I mentioned that we added is the risk-based prioritization recommendations. So you'll notice in the recommendations view, we added new recommendations for the container image scanning. And taking a closer look at them, you'll notice that the changes that we provided here um, really impact the affected resource. So previously we were showing the affected resource as the registry or the Kubernetes cluster. Now we've changed that to the image and the container. So I've already gone ahead and pulled up a couple of examples for us to look at, and we can start with the recommendation that reports on container images in the registry. So as I mentioned here, the affected resource is the container image, and you still have all the same information as before. So it will still show you the repository that this image exists on, and you still get an overview of the total findings that were detected and also the severity of these findings. In addition to that, you can also see the image URI and the digest as well. You'll notice here there's a tab for the findings, which show you the vulnerabilities that were detected on the image. And then when you click those vulnerabilities, or when you click the detected CVE, you still get the description and some background information on what we detected here. So we start out with the description, which shows you a summary as well as the impact and remediation. You can also see the severity, the CVSS score, and the CVS version. And you can also see if a fixed status is available, as well as the fixed version and the installed version for the CVE. And one of the cool things that we've added with the MDVM scanner is the exploitability. So here you'll see different fields. So if this CVE exists, if there have been any exploit steps published for the CVE, if those exploit steps have been verified, and if the exploit exists, if there exists an exploit kit for the CVE. So another way for you to prioritize remediation of the different vulnerabilities that were detected here. And you can still see, other instances of when the CVE was detected as well. So the main thing I want to call out here is that we just changed the affected resource, which is showing you the image. And then in addition to that, so this recommendation shows us images in the registry. And then for the running images, you're seeing the affected resource as the container. And in this case, we can still see the cluster that this container exists on. And when we scroll below, we can still see different insights here, such as the controller details, so viewing the pod, the controller type, and the namespace for the container. And then when we go to the findings, the same information exists here, where we're giving a background on the detected vulnerability. So we'll be able to see a description here, so the summary and remediation. And you can find the same insights, such as the fixed status, severity, CVSS score, and version within this pane. Another thing that I wanted to discuss as part of what's new is the support for the Kubernetes CIS benchmarks. So when we onboard using GCP as an example, when we onboard the project here, you'll notice in the security policies, the option to enable the CIS for GKE. So you'll see different standards here. And then when you scroll down, you'll see the option for CIS Google Kubernetes Engine. So you can turn that on the GCP project. And then from there, we start monitoring for GKE as part of CIS. And then within the regulatory compliance blade, you'll also notice the addition of the CIS GKE benchmark, which is listed here. And then when you expand the compliance controls, you can see any outstanding recommendations that still need to be remediated for the GKE cluster. And these are the main things that I wanted to highlight here for the security posture side. So with that, I'll hand it over to Vasavi to discuss the threat protection.
Yeah, thank you, Future, for a wonderful walkthrough of the posture management capabilities. And here I'm going to present about the runtime threat protection capabilities within Defender for Cloud for containers. So uh, here comes, sorry. So here comes what's new with runtime threat protection. So you see the general availability for Defender for containers in AWS and GCP is available. And then there are auto provisioning for Defender for containers in AWS. So initially when we announced the threat protection for AWS, the onboarding experience was to onboard each cluster by cluster. But we now have the auto provisioning for Defender for containers in AWS, where at one stretch you can onboard all your AWS EKS clusters through auto provisioning. Then we have announced the new threat detection sensor, which is eBPF based threat detection sensor. So earlier, the Defender agent for container was actually based on Sysdig tool, but now that it is based on the eBPF technology. So I will discuss more about this sensor again. And yeah, we also have the Kubernetes audit logs being integrated into Microsoft XDR portal, and we can perform advanced hunting queries on the XDR portal for any threat detection. And you can also configure custom rules within the XDR portal, and we can configure alerts for detected rules, and we can also configure response actions in response to those alerts. So let me walk you through each of these capabilities. So as we have seen, container security posture capabilities are mainly based on agentless Kubernetes discovery and agentless vulnerability assessment, whereas runtime protection capabilities are real-time and are based on both agentless and agent-based. So agent-based, so here we call it as sensor. So the sensor-based threat detections are available. And also, please remember that runtime capabilities are part of Defender for Containers plan only. The agentless capabilities can be provided through Defender CSPM plan or Defender for Containers plan, but all the runtime threat protection capabilities are only available through Defender for Containers plan. Then runtime threat protection is provided for Kubernetes at Kubernetes cluster level, node level, and workload level, which includes the pods, services, deployments, ingress, and your other services as well. And control plane threat protection, agentless threat protection is coverage is based on analysis of the Kubernetes audit logs, which I will walk you through how this is done. And workload threat protection is achieved through the Defender sensor, as I said, and the detections leverage the various inputs that are given to Defender for Cloud, like the threat intelligence or the behavioral analysis and anomaly detections that are mapped to the Kubernetes MITRE attack matrix. And customers can automate their responses to the alerts through logic apps or by integrating with any of your third party SIM or the source solutions as well. And finally, we also have this new integration of Kubernetes audit logs into Defender XDR, which empowers the SOC teams to investigate any suspicious Kubernetes control plane activities that are happening and that are ingested into XDR advanced hunting. So here we see multi-cloud threat protection, which is generally available now. And here we released the support for AWS and GCP. So here under AWS, we cover protection for AWS EKS clusters and as well ECR repositories. And under GCP, we cover the protection for Google Cloud GKE clusters and artifact repositories and Google other repositories as well. And here, as I said, the onboarding experience was a little different earlier. Now that what has changed or what's new here is the onboarding experience is now seamless. So you just have to onboard using the new cloud formation template, and the auto provisioning capability gives you, the capability to deploy or onboard all your EKS clusters at once. So let me walk you through this, how this looks like in the portal. So here in the environment settings, go to the AWS connector and or you add your environment for your AWS Amazon Web Services or the Google Cloud account. And here specify a name, and here onboard your either single account or management account and select the regions for AWS, and then select the subscription and select a resource group. And here you give your AWS account number, and here you select the plans. So here when you select the plans, there are things that you need to set up here. So you need to turn on the agentless threat protection, which has to be on. And also you see that the agent based, which is the auto provisioning of Defender sensor for Azure Arc should be turned on, and auto provision Azure policy extension for Azure Arc should be turned on as well. And agentless discovery for Kubernetes should be turned on, and agentless container vulnerability assessment should be turned on and saved. So here, when you are trying to deploy this, as I said, agentless threat protection, which is getting all the Kubernetes audit logs. It can be your runtime audit logs as well. Whenever any API call made to the Kube API server, all these logs are being sent to Defender for Cloud and analyzed there. So all the control plane logs are sent during runtime through agentless threat protection. And similarly, the agent or the Defender sensor, which is deployed as a daemon set within your cluster, within your EKS cluster or GKA cluster, which is deployed as a Azure Arc extension. And this sensor is going to capture the security logs on your EKS cluster and send it real time to Defender for Cloud. So this is going to be deployed as a daemon set on each and every node within your EKS cluster. And similarly, the Azure policy extension for Azure. This is also deployed as a Azure Arc extension, and this will be deployed as a gatekeeper extension, and this will be one instance per entire EKS cluster that will be deployed. So once you select these settings and save, and then you go to your deployment here. So one thing that I want to highlight here is about the pricing of the containers plan for multi-cloud, that is AWS and GCP. So until May, until the plan for multi-cloud has gone GA. This was customers were not charged for the containers plan for AWS and GCP, but since last month, that is May onwards, the containers plan for AWS and GCP pricing has started, and it is going to be $7 per VM core per month. And once you configure all these settings and you go to configure access, you can deploy your AWS CloudFormation template. Either you need to download your CloudFormation template here. So what has changed earlier? Earlier, as I said, if you have 10 EKS clusters, you had to onboard each cluster one by one. But now that with the new onboarding experience, you don't have to do any change here. You just need to deploy your CloudFormation template. So if any of the customers have onboarded or used the previous onboarding method, you just need to download the new CloudFormation template, download the after all the settings, download this AWS CloudFormation template and deploy into your AWS environment. So this is the experience that you get with the new onboarding experience. Yeah, going back. As I said, there is a new threat detection sensor that we have announced recently. So in February, so Defender for Containers has released its new sensor component, which is powered by Inspector Gadget. So this new sensor will collect the events at the kernel level and the insights, which includes the events from the host and as well as the container level. And this strengthens the runtime protection capabilities, like the new sensor also supports AMD 64 and ARM 64 nodes. So if any customers who choose to use ARM 64 node pools in AKS, the only prerequisite here is they need to use Kubernetes version 1.29 and above. So this is a requirement, and you can also see that if you are using the new sensor, if you have AKS, EKS, GKE, and on-prem Arc-enabled Kubernetes environments, so you can use this sensor as well. So this ARM 64 processor provides low power compute for your Kubernetes workloads. So customers who prefer to use this can just remember that this is only the requirement that you need to be on AKS version 1.29 and above. There is no other action required from your end to use this facility. And then Defender sensor, as I said, it is deployed as a daemon set on each node within your Kubernetes cluster, and it collects signals from hosts and provides runtime protection. And this new sensor enhances our threat detection capabilities with over 60 Kubernetes aware detections. So I encourage everyone to go ahead and use the new sensor capabilities by upgrading to AKS 1.29 version. Then comes the new announcement about some of the alerting capabilities. So as we have announced, Microsoft Defender for Cloud is now integrated into Microsoft XDR portal. Here security teams can now access Defender for Cloud alerts and incidents within the Microsoft XDR portal. And this provides richer context to investigations that can span across cloud resources, devices, identities, and all. So what is the added value here with this integration? The security operations teams can have protection, detection, investigation, and response capabilities to protect any attacks on device, email, the collaboration platforms, or your identity and cloud apps, all in a single pane of glass. And so all Defender for Cloud alerts and incidents, including multi-cloud alerts, will be integrated to Microsoft XDR portal. And these alerts and incidents are automatically correlated, providing robust context security to the operations teams to understand the complete attack story in their cloud environment. And another addition here is all the information about cloud audit events for various cloud platforms that are protected by Defender for Cloud is also available through the cloud audit events table in advanced hunting. So I will walk through these capabilities, how it works. So what do you need for this integration between Defender for Cloud and XDR portal? The prerequisite is when you enable Defender for Cloud alerts are automatically integrated to Microsoft XDR portal for free, and you don't have to do any further steps to integrate them. But there are certain prerequisites like the permissions that you need. So the permissions, you must be a global administrator or a security administrator in Azure Active Directory to view Defender for Cloud alerts and correlations for users that don't have these roles. The integration is available only by applying unified role-based access control roles for Defender for Cloud. And also you all need to enable any Defender workload plans, and these are the prerequisites to avail this integration. You can also create custom detection rules here for each of your alert. So you can create your own custom detection rules and you can alert based on custom detections. So with custom detections, you can proactively monitor for and respond to various events and system states. It can be including any suspected breach activity. Uh, you can also write custom detection rules to detect threats that are specific to your environment, and this is made possible by customizable detection rules that automatically trigger alerts, or also you can also configure the response actions for these alerts and custom detection rules. And you can set the custom detection rule to run at a regular interval, and these can generate alerts, and also you can configure the response actions whenever these detection rules matches and the alert is triggered. You can configure the response actions as well. So I will walk you through this, through all these things. And next, the next capability that we have is the advanced hunting for Kubernetes. So as I said, Kubernetes Kube audit events in Azure and Resource Manager Cloud Audit are available in advanced hunting in Microsoft XDR portal. So just to give a context here, what is Kube audit logs? Kube audit logs will capture all the activities generated by users, by applications that use the Kubernetes API, and by the control plane itself. So Kubernetes Kube audit events from Azure AKS, AWS EKS, Google GKE, and on-prem Kubernetes logs are sent to the XDR portal. So the prerequisite to hunt for threats with regard to your Kubernetes environment is having Azure Kubernetes Service deployed, or EKS, AWS EKS, that is being deployed in your environment, or it can be any of the Kubernetes environment in the multi-cloud that must be deployed. And on the Defender for Cloud side, the prerequisite is that you should have Defender for Containers plan and Defender for Azure Resource Manager plan enabled. And as I said, these events, the cloud events, are being sent into cloud event table in advanced hunting, and that will allow you to hunt through cloud audit events in Microsoft Defender for Cloud and create any custom detections to surface any suspicious Azure Resource Manager and Kubernetes Kube audit activities. So, as I said, the cloud audit events table in advanced hunting schema contains information about all the cloud audit events for various cloud platforms protected by Defender for Cloud. It can be GCP or AWS or Azure. And besides that, it also contains the Kubernetes audit logs and other cloud platforms as well. So let me take you through this portal. So here comes the portal for XDR. As I said, all the alerts that are generated by Defender for Cloud are sent to the XDR portal here. So here you see the source, detection source is coming from Defender for Cloud, and the source of it is Microsoft Defender for Servers. So here all the alerts and incidents are integrated into the XDR portal. And here you see the alert info that is coming from Defender for Cloud. If we look at any of these alerts, I think we can go through one of these alert. So say the alert that is coming as a suspected brute force attack attempt. So this is coming from the Defender for Cloud, and the detection plan or the workload plan that detected this particular alert is coming from Defender for Databases. Or if you pick any other alert, maybe I can pick another alert here. Yeah, so here you can see there is another alert that is saying suspicious authentication activity, which is coming from, again, Defender for Cloud as the source. And the plan or the workload plan that detected this particular alert is coming from Defender for Servers. So the alerts, if you can click on any of these alerts, you can see, as I said, you can also correlate these alerts with multiple other sources that are coming to the XDR portal. So here, if you look at any of this alert, you can also see the multiple alerts and the incidents that are associated with this. So this particular alert, you can see it is a multi-stage incident involving initial access and execution on multiple endpoints, which is reported by multiple sources. So if we take a look at this particular one, you can see this is a multi-stage alert that has come up. So here you see there are multiple activities that are coming up with suspicious authentication activity, file integrity change, and all this. You can also go through the incident graph on each resource and each incident point. So you can also manage this incident that is through the XDR portal. Yeah. So the next thing, apart from integrating the alerts and incidents to the XDR portal, I also told that there is this advanced hunting capability that all the cloud audit events are being sent to the XDR portal. So here you can see the cloud audit events which are sent to the XDR portal, and under advanced hunting, you can go through all the you can create your own queries and hunt for any suspicious activities within your cloud environments. And as I said, the data source for this, you can see it, the data source can be from the cloud audit events that are coming to this XDR portal, could be from not only Azure ARM logs. You can also see that the AWS Cloud Trial and GCP logging are also being sent to this one. So whatever the connectors you have within your Defender for Cloud, all the multi-cloud logs are also brought into this XDR portal, and you can do a further investigation on your multi-cloud environments as well. And here you can see the Azure resource IDs, the AWS resource IDs, and GCP resource IDs as well. Then as I said, you can also configure the detection rules. So the detection rules that you can configure for each of these, and you can configure the alerts for each of these detection rules. So you can configure the query and create a detection rule, and you can trigger an alert saying that what should be the alert name, what is the severity of the alert, and you can also configure what should be the actions on detection of this particular one, whether it should only just create an alert or should there be any response action as well. So this is about configuring your detection rules within the XDR portal. So let us try to understand, as I said, the Kubernetes audit events are also being sent into the XDR portal. So here, let me walk you through how this correlates between the various sources. So here within Defender for Cloud, as I have one alert which says abnormal activity of managed identity associated with Kubernetes. So let us dig deeper into this particular alert, and you see this is a abnormal activity that is triggered by this managed identity. And this says this alert is coming from the Azure Resource Manager operations, and this is detected as a abnormal behavior from a managed identity used by an AKS add-on. So if we look into what exactly the operations that are performed by this managed identity, you can see there are list keys action that is performed by this identity on a storage account, right? So to drill down further, maybe we can go to the advanced hunting, and we can actually look into what exactly is happening here. So here I try to run the query within the advanced hunting. So the analysis of Azure Resource Manager operations and the abnormal behavior is detected by this managed identity. So if we see how this abnormal activity incident that is associated with this managed identity, here if I run this query, I can see that this managed identity tried to perform a list case operation, and this identity actually downloaded multiple objects from the cloud storage. So this may indicate that an attacker's attempt to download sensitive data from a bucket in the cloud environment. So any such malicious activities that can be detected using your advanced hunting capabilities within XDR portal. Also, say if there are any malicious activities that you want to track within your Kubernetes environment, say suppose you want to look into, say whenever there is a privileged pod is deployed into your environment. So here I have a query which says to query my environment and see if there is any privileged pod that is being created. So when I run this query, I can see, I can fetch the record if there are any such events within my environment. So I see that an identity created a Kubernetes pod with a privileged container. So this kind of activity can be considered as a adversary trying to attempt to assess that host file system or trying to gain root access to the host. So if you want to detect any of these malicious activities, just run this query, and you can also see the logs here if any of these malicious activities that are happening within your environment. Also, here I have another query which says if I have any creation of cluster admin role binding is happening within my environment. So what this indicates is this super user can perform, so the cluster admin, which is considered as a super user within the Kubernetes environment, can perform any action on any resource in a cluster. So you can use this in a cluster role binding to grant full control over every resource within the cluster and in all the namespaces. So you can actually detect these kind of threats within your Kubernetes environment, and you can also create a detection rule, and you can also configure to create alert into your system, and you can also take a responsive action. So here you can configure the go to manage rules, and you can create a custom detection rule, and you can configure the detection rule to create an alert, and you can also take a responsive action for this or any other kind of queries. So there is a cluster role binding, or say creation of a cluster admin role binding is performed here. So you can see what activity that has been performed, and whether if your uh, Kubernetes environment is trying to, if a managed identity is trying to create a privileged pod within your environment, or if some attacker is trying to gain access to your entire cluster by creating a cluster role binding within your environment. So these kind of things can be tracked within your environment using the advanced hunting capabilities. So these are the things that I have. So let us go back to our presentation. So this ends what's new within the containers space for your entire thing. So if you have any questions, I think we can have few minutes time to take your questions here.
Thank you, Wasavi, as well as Future. This was great information to share with our community. So yes, we did get quite some questions, which most of them, in fact, all of them were answered. But we can perhaps, since we have just 4 minutes left, we can elaborate further on the feedback that we got regarding the vulnerabilities being detected, or the feedback goes like vulnerabilities detected are available from within the Defender for Cloud portal and API. So this experience having to go back and forth between two portals isn't ideal. If I know Future, you provided some documentation, some resources to this question, but perhaps maybe one of you can further elaborate on this.
Yeah. So I just want to clarify here that so as I mentioned, we're using the Microsoft Defender Vulnerability Management Scanner, but the results are not available in the two portals. So the results are only available in the Defender for Cloud portal. And you can also access the scanning results via API. So there's no need in this case to go back and forth between two portals. If you're using the portal, everything that you need is in the Defender for Cloud portal.
Right. Well, I don't see any new questions come in, so I think this will do it, and we'll wrap it up here. Again, thanks to you, Vasavi, and Future, as well as to the SMEs in the background who help answering the questions. And to all the listeners still on the line, if you're someone who wishes to aid in protection of the world from cyber threats and desires to have a say in shaping our strategies, blueprints, and recommendations, then we can invite you to participate on our customers at the private community, which is the link was shared already at the beginning of the call. That's the same link for the folks who had raised some feedback and questions about roadmaps and upcoming features. So as you understand, this is a public community call. We cannot disclose those with you, and that's why we're guiding you to subscribe to our private community, which you'll have to go through the NDA process in order to become a member of. For those of you who may have additional questions on the topic that we just covered or other product related questions, please feel free to raise them on our Microsoft Tech Community discussion space area. The short link for that is the aka.ms/MDC community. Thank you all for being part of our community and for joining us on these webinars. We hope to see you next time. Goodbye.